Hi, this is Mrs. Myers, and this is going to be a video showing you how to do all of the problems on the review for the tests for pre-calculus. Our last test before the seniors leave, 7.5, 8.1 to 8.2, so it's parametric equations and vectors. Okay, so I have it separated here into the two sections labeled. Parametric equations is first. The test is labeled the same way, so parametric equations comes first. This one says to write it in rectangular form on this interval for t, and then we're also going to graph it. You should think of these two tasks as separate things. I'm actually going to graph it first. So I'm going to take my interval for t, and I'm going to put in -2, -1, 0, 1, 2, and that is, each of these is going to get plugged in for t to get our x, and then plugged in for t here to get our y. So -2 plugged into the x, I'll do the x's first. -2 plus 3 is 1. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And 2 plus 3 is 5. So that's all our values for x. For y, we plug in t to this equation. So -2 squared is 4, minus 7 is -3. -1 squared is 1, minus 7 is -6. 0 minus 7 is -7. 1 minus 7 is -6. And 2 squared minus 7 is -3 again. Now, when you put this on your graph, you're not graphing the t's. You're only graphing the x, y's. So each of these points, x, y, 1, -3 will be on our graph. 2, -6 will be on our graph, etc. So when I go to graph this, my x values need to be between 1 and 5. And 1, 2, 3, 4, 5. And my y values need to be from -3 down to -7. So I'm going to make sure I go to -7 here. Okay, so I'm going to graph the point 1, -3, and 2, -6, and 3, -7, and 4, -6, and 5, -3. And this is what your part of your parabola looks like here. Okay? Now, the other thing we were supposed to do is write this in rectangular form. That is when you solve the x equation for t. So you're going to subtract 3 from both sides to get t by itself, and t equals x minus 3. Once you have what t equals, you plug it in to the y equation. You get y equals x minus 3 squared minus 7. Don't forget you have to FOIL this out so you get your middle term. And it's x squared minus 6x plus 2. And that's your final rectangular form of your equation. Okay, so part B, same idea, again on this interval. When you plug in t for x, you get -2 squared plus 8, so that's 4 plus 8 is 12. And -1 squared plus 8 is 9, etc. Those turn out to be that. Now we plug t into the y equation. 5 times -2 is -10, minus 1 is -11. 5 times -1 is -5, minus 1 is -6, etc. Notice that in the part A, our linear was the x and our quadratic was the y. In part B, our quadratic is the x and the linear is the y. So this is going to, I'm expecting this to be a sideways parabola. Okay, again, these are our points, 12, -11, 9, -6, etc. So my x values go between 8 and 12, really. And my y values are between negative 11 and all the way up to 9. So I need to make my intervals here. Make sure this goes up to 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. And I need to go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I'm going to graph the point 12, negative 11. I didn't quite make it far enough down here. 5, 6, 7, 8, 9, 10, 11. So 12, negative 11 is down here. And then 9, negative 6 is about here. And then 8, negative 1 is here. And then I'm back to 9, positive 4. And then 12, positive 9. So this is going to go sideways parabola like this. Okay, now again, write these in rectangular form. We just need to solve the x equation for t. So I'm going to subtract 8 from both sides, and I get x minus 8 equals t squared. Square root both sides, and t equals the square root of x minus 8. So now I just plug that right in for t, and y equals 5 times the square root of x minus 8, and then minus 1. That's your final rectangular form. Okay, now some word problems with parametrics. These are the equations we're going to be plugging into for horizontal distance, vertical distance, whoops. And don't forget, in this equation, they write it this way, but when we put it into standard form, this term is going to end up first, because that's our t squared term. So that's the one that ends up negative 16t squared, usually in the beginning. If it's feet, this is for feet, 32, the gravitational pull for feet is 32, and for meters, it's 9.8. So your first term is always going to end up either negative 16t squared or negative 4.9 t squared, depending on if you're feet or meters. Okay, here we're doing rectangular form. Oops, this is not a word problem yet, but rectangular form with theta. We want to isolate theta, so we're going to divide by 3 on both sides. And we get cosine theta equals x over 3, and sine theta equals y over 3. And then we're going to do sine squared plus cosine squared equals 1. So you're going to end up with x squared over 9 plus y squared over 9 equals 1. This one, same process, divide by 10, divide by 9, right? You're going to end up with x squared over 100 plus y squared over 81 equals 1. Okay, let's do a word problem. Ryan attempts a 43-foot field goal. He kicks the ball at 41 degrees. By the way, on the answer key that I put on the back, I wrote the wrong answer down here for this one, so we're going to do it the right way this time. Okay, so Ryan attempts a 43-foot field goal. So here's Ryan, here's the field goal. 43 feet is how far he's trying to kick this ball. It's 43 feet to that field goal. He kicks the ball at a 41-degree angle, right, at a speed of 70 feet per second. And the goalpost is 15 feet high. So we're trying to figure out that if he kicks this ball in this way, how high will the ball be after it's gone 43 feet? If it's more than 15 feet high, then he'll make it. And if it's less than 15 feet high, then he won't. Of course, it has to go between the uprights also, but, we're not really figuring that part out. Anyway, so we always start these word problems by plugging into these equations for x and y. Okay, so we're going to get our x equation is initial velocity 70 times cosine, remember the x is always cosine, of the 41 degrees, and then do a t at the end. Now, that turns out to be x equals 52.83 t. Okay, so there's our x equation. Our y equation is in feet, so it's negative 16t squared plus, now we got 70 sine this time of 41t, and then it's plus 0 because he's kicking this ball off the ground, so the initial height is 0. This turns out to be y equals negative 16t squared plus 45.92 t. There's our y equation. Okay, so what we're trying to figure out is how high that ball is after it's gone the length of 43 feet. So 43 feet is a constant that we know. We know that, and that's the horizontal distance that this has to go. So since x is our horizontal distance equation, we're going to plug the 43 in for x and solve for t to see how long it takes for it to go 43 feet. Divide by 52.83 on both sides, and t turns out to be 0.81 seconds. So it takes 0.81 seconds for this to go 43 feet. What we want to do now is take that and plug it in for t here, because plugging it into the y equation will tell us how high the ball is at that many seconds. So when we plug this in for t, we get y equals negative 16. Just the 0.81 gets squared, plus 45.92 times 0.81. When we do this out, we get that y equals 26.7 feet high. So does he make it? As long as it was a straight kick, it's high enough to go through the goalposts, because the goalposts are only 15 feet high. So yes, he makes it. All right, Stephanie hits a tennis ball. You'll notice a lot of familiar names in this and on the test. Stephanie hits a tennis ball 55 centimeters above the ground at an angle of 15 degrees with the horizontal. The ball has an initial speed of 15 meters per second. Write the parametric equations first. So, like I said, always start with writing the parametric equations anyway. So this is x equals 18 cosine 15 degrees t, and it turns out to be 17.39 t. This is y equals, since we're with meters now, right, meters and centimeters, this is negative 4.9 t squared plus 18 sine 15t plus 0.55, because we're in meters here, so centimeters, 55 centimeters is 0.55 meters. Okay, so this turns out to be y equals negative 4.9 t squared plus 4.66 t plus 0.55. All right, so the question is, so those are the two parametric equations. The question is, how long does the ball stay in the air before hitting the ground? So we want to know how long the ball's in the air. So that's t. We're solving for t before it hits the ground. So that's the vertical distance. That's our y. It comes back down to the ground. So we're going to set y equal to 0 in this equation. Now I would put this into my calculator. This is y1. This is y2. And then second calc intersect. And only do the second intersection, the one that's on the end of the ball path. Okay, so it ends up intersecting at t equals 1.06 seconds. That's how long the ball is in the air. If Stephanie is 10 meters from the net and the net is 1.5 meters above the ground, will it clear the net? So this is just like the one with the football kick. We know it needs to go 10 meters horizontally, so we're going to plug that into our x equation. and see how long the ball's in the air before it reaches the net. And t turns out to be 0.575 seconds. So now I'm going to take that and plug it in for y. Well, sorry, not in for y, but in for t in the y equation. And this is what this comes out to. And it turns out that y equals 1.61 meters high after it's gone the 10 meters. So since the net is only 1.5 meters high, yes, it goes over the net. Okay, I am going to stop this video and I'm going to make a second video with the vectors. Okay?